Hello, dear students. I'm Aditya Gupta, and a very warm welcome to the second lecture on the topic of a pair of linear equations in two variables. Earlier, we have seen what it means to solve a pair of linear equations in two variables, simultaneous equations, also we can call them. And also, we have seen the substitution method that can be used to solve them. Now, in this particular lecture, what we are going to do is to take a look at these topics: elimination method and the cross multiplication method, right? Now, as far as elimination method is concerned, what we do is that we either add or subtract the equations to get a to get equation in one variable. Now, why is this justified? Sometimes students think that why is it justified to add equations? Why is it justified to subtract them or even multiply them or any such thing? So the justification comes from the fact that if A is equal to B and C is equal to D, then any operation involving A and C, we can always replace A by B and replace C by D. So that's why. So any such thing, let's say you want me to do A plus C, then I can say A is equal to B and C is equal to D. So obviously this will be, I have just replaced the values of A and B. But in effect, we can say that I have added the equations A plus C and B plus D. So LHS and RHS I have added of both the equations. So it looks like the equations have been added, or we can say that LHS and RHS of both the equations have been added. But justified it is because A has been simply replaced by B, C has simply been replaced by D. Similarly, you can subtract also that A minus C would be equal to B minus D, because I have replaced A by B because they're equal, and C by D. But in effect, it looks like we have subtracted the equations because LHS and RHS, they have been subtracted. Look, if I subtract these two equations, I will get A minus C and I will get B minus D. So even on subtracting, we are obtaining the same thing, which is true. Similarly, we can multiply also. Okay, so A into C equal to B into D. Okay, so the reason that multiplying, dividing, or adding or subtracting equations is also allowed is because it is justified by the fact that A can simply be replaced by B and C can simply be replaced by D because they are all equal. So that's why the two sides will still be equal, right? Now, we basically add and subtract after multiplying by a suitable coefficient, okay? So that's important to understand, right? So that only one variable remains. So when coefficients of one variable are opposite, we can add to eliminate the variable, and when the coefficients are equal, we can just subtract the equations to eliminate a variable. Okay, so for instance, in our case, here we have been shown an example. So we have simply subtracted both these equations because 10y and 10y are here. So it will get cancelled if I subtract the equations. 13 minus 14 is minus 1. 7x minus 6x is x. 10y minus 10 is cancelled. So we get the value of x is minus 1, right? So now let us have a look with the help of an example how elimination method works. So let us say you have a random equation minus x plus let's say 5y is equal to 2, and let's say another equation 3x plus 7y is equal to 4, let's say, and we want to solve for x and y. So what we can do is, let us say I multiply this equation by 3 so that I get a 3x here also, right? So I am multiplying this equation by 3 on both sides. So of course that is allowed, because we on both the sides of an equation, if we are doing the same thing, it is allowed. So 2 into 3 will give us 6, and 3 into this thing will give us minus 3x plus 15y. Now let us add these two equations. On adding, what are we getting? 4 plus 6 is 10. 3x and minus 3x, when they are added, 0. 15 plus 7 is 22y. So y comes out to be 5 by 11. 10 by 22, cancelling by 2, we get 5 by 11. As soon as we have got the value of y, just plug in that value in any of the equations and you will get the value of x. So for instance, if you put here, you will get minus x plus 25 upon 11 equal to 2, correct? So x will come out to be 25 upon 11 minus 2 into 11 if I take LCM. So x comes out to be 3 by 11, okay? So that's the basic, method of solving, that we try to eliminate one variable by suitable addition or subtraction of the two equations. That is the essence of the elimination method. Okay, so now let us also take a question. Two pens and one eraser cost rupees 35, and three pencils and four erasers cost rupees 65. Okay, so find the cost of one pencil and eraser separately. So look, what we can say is, let us say cost of one pen, or let us just write here pencils. So cost of one pen, let us assume, is P, cost of an eraser is E. So two pencils will cost 2p, and one eraser will cost 1e or e. So they together cost rupees 35. So this plus this will give us 35 rupees. Three pencils, four erasers together cost 65 rupees. We have to find cost of, okay, p and e basically, right? So just multiply this equation by 4. The reason we are doing that is to obtain 4e here also. So doing that, we are getting 140 rupees. 140 is equal to 4e plus 8p. Now from this equation, subtract this equation. So, or let me write it here to avoid confusion. I will write this equation once again here. And now let us subtract this equation. So we are getting, why are we subtracting? Because 4e and 4e we can't add, otherwise it will not be eliminated. We will get 80. To eliminate the term of e, we are subtracting. Okay, so 140 minus 65 will be 75, correct? And here 4e and 4e will get cancelled. 8p minus 3p will be 5p. Okay, so P comes out to be 75 by 5, which is 15. And E comes out to be, from this equation, 35 minus 2 times P. So this comes out to be 5 rupees. Okay, so which is the answer also. So that's how we can easily use elimination method to solve the given question. And of course, our answer matches with the given answer. Eraser cost is 5 rupees. Pencil cost is 15 rupees, as we have obtained here as well. Here also they have multiplied by 4 and then subtracted the equations, and we have got the final answer. Fine. So this was how we can use elimination method. Now talking about cross multiplication method, it is basically a method which is easily derived using elimination method itself. So first of all, let us have a look at what this tells us. In mathematics, the cross multiplication method is used to solve linear equations in two variables. This is the simplest method and gives the accurate value of the variables. Cross multiplication is only applicable when we have a pair of linear equations in two variables. So let us suppose that these two equations are given. So a1x, okay, plus b1y plus c1 equal to 0, and a2x plus b2y plus c2 equal to 0. These two are the equations, then which has to be solved, right? So using cross multiplication method, we will get all of this, which, and we are assuming this is not equal to 0, so the final solution can be represented in this form. Now you might be thinking, where did this come from? So let us first derive this, how we can derive this thing. So consider the equation a1x plus b1y, okay, plus b1y plus c1 equal to 0, and also consider the equation a2x plus b2y plus c2 equal to 0. Now let us try to solve this by elimination. So what if I multiply this complete equation by a2 and multiply this complete equation by a1? Okay, so on both sides, if I multiply this equation by a2, what are we getting? A1 A2x plus A2 B1y plus C1 A2 equal to 0. If you multiply this equation by A1, what are you getting? You are getting on both sides, you will get A1 A2x plus A1 B2y plus C2A1 equal to 0, correct? Now, if we subtract, what's happening? If I subtract this equation from this equation, we will get 0 minus 0 is 0. Now, this and this will get cancelled, correct? And what about this? We will get A2B1y minus A1B2y plus C1A2 minus C2A1. So from here, if I take y common, we are going to get, and if I transpose this to this side, we are getting that we are getting y is equal to C1. So look, we are getting C2A1 minus C1A2 divided by A2B1 minus A1B2. Okay, so that's what we are getting the value of y as. And here we have written y as C1A2 minus C2A1, but we are getting C2A1 minus C1A2, but they both are equal. The reason is that if you multiply this equation on both numerator and denominator by minus 1, let's see what we are getting. Look, we can write this as A2B1 minus A1B2 into minus 1 upon minus 1. Okay, the reason is that if we can obviously multiply numerator and denominator by the same term. Okay, so then this will also give us C1A2 minus C2A1 upon A1B2 minus A2B1, which is precisely the same quantity as that given here. Okay, similarly we can also solve for x using the same method. So what we can do is that we can now eliminate y. Okay, so the way we can do it is that what we are saying is, okay, let me just yeah, look, what we are saying is to find y we have found, but how will we find x? So look, obviously we should we should eliminate y, but to eliminate y, what should we do? This equation we will multiply by b2, and on multiplying by b2 we will get a1 b2x plus b1 b2y plus we are multiplying by b2, right? So b2 c1 equal to 0. This will multiply by, can anyone guess, any idea? To eliminate y, what should we multiply this equation by? Don't you think it should be b1 on both the sides of the equation? We should multiply by b1. So doing that, we will get b1 a2y plus b1 b2y plus b1 c2 equal to 0. That's what we are getting. Now if we subtract these equations, we will get, look, 0 minus 0 is 0, b2c1 minus b1c2 here, and then this and this will get cancelled, and x and this minus this, let us take x common, or okay, first let us just subtract, then we will take x common. So that's what we will be getting, okay, on subtracting both the equations, right? Now, from this equation, if you take x common, finally you will obtain this result, this value, b1 c2 minus b2 c1. Okay, if you take it here, b1 c2 minus b2 c1, right, divided by a1 b2 minus b1 a2. So that's what it is, b2 a1 minus b1 a2, b2 a1 minus b1 a2. So that's all something that we are obtaining as well. So these two formulas we have derived. Now, how can we say that this can also be written in this form? Well, obviously that's true, because from this equation you observe that x upon b1 c2 minus b2 c1 is equal to how much? 1 upon b2 a1 minus b1 a2. So that's what this equation is also telling us with these equalities. And from this equation also you are getting y upon c1a2 minus C2A1, right? Minus C2A1. That is also coming out equal to 1 upon B2A1 minus B1A2 only. Okay. So that's what we have here also. B2A1 minus B1A2. So that's why, to remember it easily, we can just remember this result. And after that, we can simply solve the equation. Now here we have assumed that b2a1 minus b1a2 is not 0. So we will also talk about this. So look, let us, right now we just got the value of y to be this much, c1a2. So let me write it down. Y is equal to c1a2 minus c2a1 upon a1b2 minus a2b1, right? So obviously if this is non-zero, then everything is fine because division is allowed. But what if a2, let us take the case when this is 0. So when this is 0, then what happens? We can say that we get equal to 0, then we will get a1 b2 equal to a2 b1 on dividing by, on taking a2 here, b2 here, we will get a1 by a2 equal to b1 by b2. So in this case what happens? So in this case we will have two cases. The first case is, let us say, okay, in this case also there are sub cases. Okay, this was already a case in itself. Now we are taking sub cases. Sub case is that what if the numerator is also not 0? So numerator, so what if numerator is not 0? So let me write it like this. If this is not 0, it means C1 A2. Okay, this is A2 by the way. Let me write it a little bit clearly. C1 A2 minus C2 A1. What if it is not 0? In other words, this is not equal to C2 A1. In other words, C1 by C2 not equal to A1 by A2. So C1 by C2. What if that is not equal to A1 by A2? So in that case, this will be, the numerator will be non-zero, but this is 0. So non-zero number by 0 is not defined. So in that case, no solution exists. Okay, this is such an important thing to understand. No solution exists because this would imply that C1A2 minus C2A1 is non-zero. This means that numerator is a non-zero number, like let us say 3. Okay, and upon 0. So why this is infinite minus infinite? Nah, because on division by 0, we don't get a finite real number. So there is no such y possible. Another way to understand this can be that if you, let us say we had obtained this equation, right? So instead of dividing, we just write it in cross multiplication form only, that y into a1b2 minus a2b1 was equal to c1a2 minus c2a1, right? Before sending it here, it was this only na. So in this case, if this is non-zero, this means this is non-zero, correct? But this is already equal, so this is 0. So this thing is 0. So 0 into y is 0. But this is non-zero. So this non-zero number is equal to 0. That is not possible only for any y. So that's why we can say that in this case, no solution will exist. Now, second case, so this was the first subpart. The second subpart will be that when C1 by C2 is equal to A1 by A2, and obviously we have already assumed A1 by A2 equal to B1 by B2. So this will also be equal to B1 by B2. In this case, there will be infinite solutions. Okay, infinitely many solutions. Okay. Now, why is that the case? Because obviously, the reason is that in this case, this will also be 0. Okay. And this will also be 0. So 0 is equal to 0 into y will always be true. Correct. So in this case, there will be infinitely many solutions. Okay. So this we need to remember. Now, apart from this, let us also understand a clever way to remember. Okay, and one more thing, what will be the condition for a unique solution? Second, so let us take it like this. This was case 1, when this is, the case 1 is basically this itself, that A1 by A2 is equal to B1 by B2. Okay, these all are equivalent only. So we can say this is the case 1. Then in that we have two sub cases. If this is the case, then no solution, and if this is the case, then infinitely many solutions. Now we have case number 2. This case is when a1 by a2 is not equal to b1 by b2, then unique solution will exist. Unique solution means one exact value of x and one exact value of y, so will exist. So only one ordered pair of x and y we will get that satisfy the given equation, because in this case the denominator will be non-zero. This denominator will be non-zero. So obviously division is always defined by a non-zero number. Okay, so we will get a unique value of y from here. Okay, now let us also understand a very easy way to remember this formula. What we can do is in this manner, that we can write x, okay, then y. A very easy way to remember would be, you first write like this: x minus y and 1. Then you write by and by. Now look, what you do is, the equations were a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 equal to 0, right? Now, when we are talking about x, then just hide the column of x, okay? Just hide this. So what are we left with? Now just write the coefficients, okay? b1, c1, b2, c2, okay? So in this box kind of a thing, you write b1, c1, b2, c2, okay? Then what about, what will come here? For if, since y is present here, you hide the column of y. And what else is remaining? a1, a2, c1, c2. We are only writing coefficients, okay? So a1, a2, c1, c2. Now, what will we write here? Since this is a constant term, these are the constant terms. So hide this column and write the remaining coefficient a1, b1, then a2, b2, okay? And how do we open these boxes? These are simply opened by cross multiplication. That's why the name cross multiplication is used. How do we open a box? So let me explain that. Whenever you have p, q, r, s, you cross multiply. So p into s minus q into r, okay? Q into r. That's how we use cross multiplication. So that's why we will get here in the denominator b1 c2 minus c1 b2, and here also we had obtained the same thing, b1 c2 minus b2 c1. That's what we obtained here also, b1 c2 minus b2 c1. Now here also we will obtain a1 c2 minus a2 c1. So a1 c2 minus a2 c1 is only here, but with a negative, due to negative sign, the order has changed here. But we have obviously put our negative sign above, so this is correct. Okay. Now here it was b2 a1 minus b1 a2, b2 a1 minus a1 b2. That's look, let us check a1 b2, or we can say b2 a1 minus a2 b1, b2 a1 minus b1 a2. Here also we are obtaining the same thing. Okay, so that's how we can easily remember this formula. Okay, and in fact this is how I recommend you all to do the questions as well. So let us have a look at the question here. Using cross multiplication, we wish to solve these particular equations. So first of all, you write it like this: 3x minus 4y minus 2 equal to 0. This you write as 2x minus y plus 7 equal to 0. What I have done is, I have taken 2x here, minus y here. Here I had brought this 2 here, okay? So now, you remember what method we have learned? X you write, then minus y you write, then 1 you write. Divide by, divide by, divide by. After that, what do we do? For x, you just hide this column and the remaining things you write in the box. So what are the coefficients? Minus 4, then minus 2, minus 1, right? This is the minus 1, then plus 7. Then under y, what will you write? If you hide this column of y, you are left with 3 minus 2. 2, 7. Okay, so that's what we have written. Now, what if we hide for constant term, you hide these constant terms, we are left with 3 minus 4, 2 minus 1. That's what we have written here. Okay, so let us see from here what are we getting. This would imply x upon, now look, you cross multiply, minus 4 into 7 is minus 28, minus, you cross multiply, minus 2 into minus 1 is 2. Okay, so that's what we have written, equal to minus y upon, here what are we getting, 3 sevens are 21, minus, what is the product of minus 2 and 2? It will be minus 4 obviously, right? And equal to 1 upon 3 into minus 1, it will be minus 3. And then we will get minus cross multiplication of this thing. So what, minus 8 obviously it will come out, right? Because minus 4 into 2 is minus 8. So we are getting x upon minus 26. This will become, sorry, minus 30 it will become. Let me rewrite this. Minus 28 minus 2 is minus 30. Here we are getting minus y upon 25 because this will become 25. And here we will get 1 upon 5 because 8 minus 3 is 5. So from this equation, x upon minus 30 equal to 1 by 5, I will get x equal to minus 30 by 5, which is minus 6. And from this equation, I will get y equal to minus 25 by 5, which is minus 5. So that's the solution, and you can check also by verify also by putting these values. So if you put in this equation y minus 5 and x as minus 6, what are we getting? 12 minus 5, which is 7. So indeed this equation is satisfied. Similarly, this will also be satisfied. So that's the way we have easily used cross multiplication method to solve it so quickly, right? Just 3 steps we have used. This was the first step, second step, third step, and we have got the answer very easily, right? And that's the solution also that is given here, x equal to minus 6 and y equal to minus 5, just the way we have obtained. Correct? Fine. Now let us have a look at some of these good practice questions here, solved by elimination method, this particular equation. Now we can easily add them because x will easily be eliminated, right? So let me write here 3y plus 2x equal to 6. This second equation is 5y minus 2x is equal to 10. So if I simply add them, I will get 6 plus 10 is 16, and this will get cancelled only. 3y plus 5y will be 8y. So y will come out to be 16 by 8 or 2. If you put this value of y in any of these equations, let us say the first equation, so what are you getting? You will get 3 into 2 will be 6 plus 2x equal to 6. 6 and 6 get cancelled. So 2x equal to 0. So x equal to 0 by 2, which is 0 only. So x is equal to 0 is coming out, which is our solution to the first question. Okay. Now, of course, we have used elimination method only to solve this. Now, second also we have to solve using elimination method. Once again, this is very, very simple. What we should multiply the first equation by 4 because coefficient of y is 4 here, correct? So then we can subtract them and easily get the answer, right? So if I multiply the first equation by 4 on both sides, you get 9 fours are 36, and here you will get 12x plus 4y. Okay, and this equation we write as it is, 5x plus 4y is 22. On subtracting, we are getting 36 minus 22 is 14, 4y minus 4y is 0, and 12x minus 5x will be 7x, correct? So x comes out to be 14 by 7, which is 2, and then you can of course put the value of x here. So 3 2s are 6, 6 plus y gives us 9, so y will be 3. Okay, that's how we can easily solve this. Now what about this equation? Using cross multiplication method. So look, we first write this equation like this, 2x plus 5y minus 20 equal to 0. And this equation we can obviously divide by 3 first, so we are getting x plus 2y equal to 4. Okay, let me explain it a little bit properly if you are not understanding. Look, what I'm doing is I have simply divided both sides of the equation by 3. Okay, so doing that, what am I getting? This becomes 4 and this becomes 3x by 3 plus 6y by 3. Correct? This 3 cancel, this cancels with 2. So that's why I am getting x plus 2y minus 4 is equal to 0. Okay, I have just brought this here. Now, how do we use cross multiplication method? You write x, you write minus y, you write 1 upon, right? Now, what will come in these boxes will come. If you hide this for x, you are left with 5 minus 20 and then 2 minus 4. Okay, so all these coefficients we have written down. Now here what will we get if we hide the column of y? 2 minus 20, 1, because obviously x means 1 into x only, so 1 and minus 4, so 1 and minus 4. Now what about this constant term? Just hide this column. What are left? What coefficients are we left with? 2, 5, 1 and 2. Okay, now on solving this, let us see what we are getting. X upon, so for the first answer we have got correct answer 0 and 2, correct here, and for second also 2 and 3 as the answers that we have gotten were correct. Now let us see for this what we are getting. X upon 5 into minus 4 minus 20 minus minus 20 into 2, which will give us minus 40, equal to minus y upon, what was it, 2 into minus 4, which will give us minus 8, minus minus 20 into 1, what is this product? Minus 20 itself, equal to 1 upon. Now what about this? 2 twos are 4, minus 5 into 1 will give us 5 only. So we are getting x upon 20, it will become, because minus minus will become plus, so 40 minus 20 is 20, equal to minus y upon, this will become plus 20, 20 minus 8 is 12, equal to 1 upon minus 1, so it is minus 1 only. From this equation, we are getting y equal to 12, and from x upon 20 equal to minus 1, we are getting x equal to 20 into minus 1, which is minus 20 itself, which is also the correct answer given here. So I hope you are able to understand this question as well. Let us just take 2 or 3 more questions, then we will end this lecture. Okay, so let's see. Here we have a question. Find, or let's say solve, for x comma y in the given equations. So equations, let's say, which are given to us are 3x plus 4y equal to, let's say, uh, let us say 7, and another equation is given to us, for instance, let's say 9x plus 12y is equal to 21, or let's say minus 21 is equal to 0. Okay, and we are supposed to solve these equations. So what we can see is first we can transform this equation in this manner. 3x plus 4y minus 7 is equal to 0. So in the form a1x plus b1y plus c1 equal to 0, we are doing that, and this equation can be written as it is, right? Now we observe that a1 by a2 equal to b1 by b2 equal to c1 by c2 is holding true, because all of them are equal to 1 by 3 only, correct? So if a1 by a2 equal to b1 by b2 equal to c1 by c2, then we can say there will be infinitely many solutions. And how can we find those family of solutions? It is not that you can put any x and any y and you will get the solution. No, that's not what we mean by infinitely many solutions. For example, if you put x equal to 0 and y equal to 0, does that work out? No, it does not work, because if you put x 0 y 0, this becomes 0, which is not equal to 7, so the equation is not satisfied. So what are the solutions which will satisfy this equation? So we can put this in many ways. One of the ways is that we can say just put x anything, let's say t, then y you can put as 7 minus 3t upon 4, where t is any real number. Okay, so this will always represent a family of solutions which satisfies this given equation. You can put any t at all. For example, let's say you put t equal to 100, then x will come out to be 100 and y will come out to be how much? 7 minus 300 upon 4. So that will satisfy both these equations actually. You can check that. Okay. How are we saying that? Because when x is t, from this equation, how much is y coming out? 7 minus 3t upon 4 only. So no matter what t you choose, you will always generate a solution. And since you can choose infinitely many values of t, because any real number you can choose, so that's why there are infinitely many pairs of solutions that we are getting. Okay, in reality you can easily see that if you multiply this equation by 3, you are obtaining this equation. So this equation is not providing us with any new information, it is just obtained by simply multiplying this equation by 3 itself, right? So that's why there are infinitely many solutions in this case. Now let us talk about this case where we have an equation 2x plus 5y, or let us say like this: 2x minus 5y equal to 7, and let us say 10x minus 25y equal to 10, let's say 14, right? Now, easily you can observe that if you want to write this in standard form, it will become 2x minus 5y minus 7 equal to 0. This equation, on the other hand, becomes 10x minus 25y minus 14 is equal to 0. And then we can easily observe that a1 by a2 is equal to b1 by b2, correct? b1 is minus 5, b2 is minus 25. But this is not equal to c1 by c2. So in this case, what happens? The reason is both of them are 1 by 5 only, right? But this is 1 by 2. So when a1 by a2 equal to b1 by b2, but a1 by a2 is not equal to c1 by c2, as we have discussed in earlier cases. Let me just remind you all that in this case, when a1 by a2 was equal to b1 by b2, but it was not equal to c1 by c2, then in that case, what used to happen? No solution exists, right? So that's what we would say here, that in this case, no solution exists. What does it mean? That no matter what x and y you put, both of these equations will never be satisfied simultaneously, okay? So it will have no solution. Now, one final question we will take, a little bit good question using elimination, and then we can call it an end, okay? So the question is, let us say 2x minus 3y is equal to, let's say, 5, and let us also say 4x plus 5y is equal to 10. So how do we solve this? Using elimination, right? So if it is given to solve elimination, what we should do is we should try to make the make coefficients in such a way that they are easily cancelled. So observe that if I want to make the coefficient of x as 4, I should multiply this equation by 2, correct? So if you multiply this equation by 2, you are going to get 10 is equal to minus 6y and 4x. Now, if you subtract this equation, you are getting 10 minus 10, 0, 4x minus 4x, 0, 5y minus minus 6y will become, okay, let me write it like this, plus 5y minus minus 6y equal to 0, okay, equal to 0. So we are getting 11y equal to 0, or y equal to 0 by 11, which is 0 only. If you put y equal to 0, you will get x equal to 5 by 2. So this is the solution, right? So that's something that we need to understand, that how do we use elimination method. Another example, which is a good question, can be that 3x minus 2y is, let us say, maybe 10, and let us say 2x plus 3y is equal to 5, let's say. So how can we solve this equation? Look, we cannot make directly, like what should we multiply this equation by? So we should multiply it by 2 because these are not multiples, right? So if I multiply this equation by 2 and this equation by 3, okay, this is another example that I am taking. So then this equation will become 20 is equal to 6x minus 4y because I'm multiplying by 2, and this equation I'm multiplying by 3, you will get 15 here, and 6x plus 9y. And now, of course, what should you do? You should subtract the equation. So 6 and 6x get cancelled, and here we get minus 4y minus 9y, which is minus 13y, equal to 20 from minus 20 minus 15, which is 5. So y comes out to be minus 5 by 30. And of course, if you will put this value of y here in any of these original equations, you will also get the value of x. So that's pretty much how we try to whatever we need to do in order to cancel one variable, that we do, okay, in elimination method. So thank you for watching, and I hope you found this lecture interesting and got to learn something new. And the methods that we learned, especially the methods of elimination and cross multiplication, you were able to understand. And we also covered the different cases when there will be a unique solution, when there will be no solution, and when there will be infinitely many solutions, right? So I hope you all were able to enjoy the lecture and learn something from it. And once again, thanks a lot for watching. Stay safe and enjoy your studies. Bye bye.